Hello everyone, I am Rohit Raj and I am from Lovely Professional University. I am here to present a presentation on compact 5 volt regulator for USB devices. As we know, there are many chargers which have unstable voltage which give 4 to 6 volt variable voltage. But we but due to this, smartphones burns their battery's life become too short. Here we come with the 5 volt stable voltage regulator for this chargers. Coming to the problems objective, we have to need to understand the design. We have to learn the basic designing of a small voltage regulator for USB devices, including circuit diagrams and simulation software. We have to explore challenges. We have to identify the challenges keeping a stable 5 volt output for reliable mobile charging, such as voltage charges, changes, and temperature effects. We also have to need to know the component selections. We have to know how to pick the right part for the voltage regulator to make it efficient. Coming to the problem of, as I discussed in the first slide, the unstable voltage. First one is variable voltage. Mobile chargers often provides variable voltage ranging from 4 volt to 6 volt depending on the power source and cable quality. This variability can lead to inconsistent charging performance and potential damage to the connected device. Coming to the voltage fluctuation occur due to variation in the input voltage from the power source and changes in the load demanded by the smartphone during different charging stages. This fluctuation can cause the charging process to be interrupted or prolonged. Optimal charging. Smartphones need a stable voltage 5 volt for optimal charging. Voltage outside this range can reduce charging efficiency, generate excessive heats, and potentially damage the battery or other internal components of the device. So it's important to avoid them. Coming to the analyzing the design requirement, we need to give input voltage of 4.5 volt to 12 volt, but it should give the output voltage up to 5 volt and our current up to 2.4 ampere and efficiency is greater than the 85% at full load. Coming to the solution, the main solution is the buck converter. And first of all, you should know what is buck converter. Buck converter is also referred to step down converter is a popular topology in power electronics that converts higher input voltage to lower output voltage. Coming to the simulation, as you can see, we have used the components battery, 12 volt battery, a DC input battery, and we have also used the LM7805 voltage regulator to convert the 12 volt to 5 volt DC output. In this, we have given it is given three pins: V1 input voltage pin, second one is ground pin, and third one is output voltage pin. Regulated 5 volt. We also used 1 kilo ohm resistor and LED indicator. The LED indicator lights up indicate power is stable, and the 1 kilo ohm resistor limits the current to protect the LED. We also used two capacitors, 0.333 microfarad capacitor and 0.1 microfarad capacitor. It is used because for noise filtering and stable voltage. First capacitor, input capacitor for stability, and second capacitor, output capacitor for smooth of 5 volt regulator. We also use emitter to display output voltage uniform that successfully regulate the voltage. We also use the J3 USB converter to provide 5 volt output for powering VCC. VCC T plus T minus ground and only VCC to 5 volt ground converter. The circuit for powering the data transfer due to star transfer. Coming to the working of this circuit, the 12 volt power source V1 provides input to the 7805 regulator. C1 stabilizes the input voltage to prevent fluctuation. The 7805 IC regulates the voltage a steady 5 volt. C2 smoothens the output voltage. The USB port G3 provides the 5 volt to connected device. Coming to the simulation result, we as you can see 88% efficiency 90 in 12 volt input and 92% efficiency in 5 volt output. Coming to PCB layout of consideration is to minimize loop area, reduce EMI with a small loop area, use ground plane, heat sinking the place capacitor close, place the input output capacitor close to the IC. Coming to the conclusion, as you can see, a synchronous buck converter make a compact, efficient 5 volt regulator. Component selection is crucial for reliable performance. So, thank you for listening.